home can see the board. Good morning, sugars. All right, so I will be skipping through a lot of this. Some of this stuff you guys already know. You do not need me to go over, but I'm going to get to the part that I want to concentrate on the most. My suggestion to you is for you to always read the section in the book. So I will be checking out books to you, but I would always, I would be reading in the book, okay? Let me get you set up. Sorry, let's just hope. Just don't fall, sugars, don't fall. Oh, it's sliding. See, we need to figure out a really good way to, okay, we're going to figure you out. I'm still here. Here we go. Okay. Can't do it in front of the see, but you can. How's that? All right, we're getting there. We are so getting there. Okay. I don't even know if you can see the board. All right, that's good. We're getting there. Okay. All right, so we're going to go through this. Again, you're going to notice I'll put some jokes in there. Y'all can read them at some point, okay? All right, if you have categorical data, this data right here is really data that only can be displayed that's not quantitative, but it is qualitative. And you guys, the screen, y'all, you can't even see anything on it right now. That's crazy. Let me shut the back things right here. Okay, so categorical data is qualitative data. So if I ask you what your favorite color is, that is not something that can be put in a box plot. If I ask you what your favorite restaurant is, that is not something that can be put in a box plot. So that is some sort of category that you are going to fall into. And I'm sorry, this is not show. Oh, look, starting to show up now. Maybe just a little bit. I really do feel bad. And I'm sorry for all the people at home that are trying to watch. Okay. It just doesn't like me today. All right, so anyways, so we know what categorical data are. So again, like I said, your favorite color, your favorite restaurant, your favorite NFL team, whatever it might be, that can be displayed either in a bar graph or it can be displayed in a pie chart, okay? All right, so here's an example. What type of radio do you listen to? Most of you probably don't listen to the actual radio. You find something that you enjoy on some sort of app somewhere, and it might be, you might like podcasts, you might love news talk radio, you might love country music, you might listen to Christian music, you might be a Joy FM person. Some of these, this is a category that you would fall into. So the only way you can really display that would be a box plot or a pie chart, okay? Here's a bar graph right here. Now this one's interesting because down here, this is numerical data on here. And this numerical data is, but it is an age group. But again, it's still a category that you fall into. Y'all, this is unfortunate. It is just a white screen that is showing up. Okay, thank you, Allison. It's still not loving it. What I'm going to try to do is turn it around. What do you think? Do you think maybe that would pick it up a little bit better? Okay. I don't think I just changed anything at all. I think... Whoop. How frustrating is this going to be to whoever's watching this? Oh, y'all, that is totally working. All right. Oh, yep. There we go. Okay, perfect. Good. All right. They're going to appreciate that. All right, so here we go. This is also your category. This is like saying we have teenagers, we have young adults, we have middle-aged. And so this is considered a category there, okay? All right, another categorical example. I just gave this one right here. What type of radio stations do you listen to? We had 13,838 radio stations in the U.S. Here are the distributions of the category, okay? Again, you can do a bar graph, you can do a pie chart. Watch out with round-off error. That sounds kind of like a gymnastics move, but a round-off error is that you might just not end up with 100%. So do not freak out about that. If you round a particular way, you might end up with 100.1%, okay? Or 99.9%, but that is round-off error, and that is not an end-all, be-all to a problem, okay? So don't worry about that. All right, again, we went through stem and leaf. We kind of went through this already. What do you need to recognize with a stem and leaf? You need to recognize the longest leaf. You need to recognize empty buckets, as I'll call them buckets, but you have an empty stem, okay? And again, a stem and leaf or a stem plot consists of all but, that should say, the final number. All but the final number. The rightmost digit is the last digit in the stem plot, okay? So how to read it, notice if there are any values that are clustered. So what is our longest leaf? What is the longest bucket? And then if there's any type of skewness, normal, symmetric pattern. So again, you're going to turn your head to the right and you're going to notice if there's any patterns that are important. So what is our highest bar? So like I said, this is almost like a histogram. It's important to notice if there's an empty bucket. This one right here looks bimodal to me. It looks like there's a peak on the lower end, there's a peak on the upper end, okay? Bimodal means that it's two peaked, okay? And we definitely have an empty bucket at 5, so we might want to look at that. Did I do the data wrong? Did I not collect enough data? Would you believe that if I collected 10 more pieces of data, something would end up in the bucket of 5, okay? Or is it just because I had too little data that's why it's empty? Or is there a reason why it's empty, okay? So we always want to think of why, how did it get there, who collected the data, okay? And what part of that is important. All right, now this is kind of fun. We can split the stems, okay? We can split stems and we can also do back-to-back. This is an example of a back-to-back stem plot, okay? Now, be careful on this one. It's not too bad. But if you notice, the males looks completely normal. So what we have here is, we have a male stem plot. This is on grades, test grades. And on this one right here, we have nothing in 2, 3, and 4. Thank goodness, because this is a test grade, okay? But we have, our concentration is from 5 all the way down to 10, which stands for 50 on a test grade. And we have 3 100ths on a test grade, okay? Now, that one, you're going to read from left to right, but if you look at the women's, you're actually reading it from right to left. So look at the order right here of the 2 females. One made a 31 on a test, and one made a 38 on the test. Okay, so do y'all see that right here? But we're actually moving from right to left. So when you put it in numerical order, you're doing it from the stem and then out of the leaf, okay? So just make sure that you're putting it in numerical order, going from the stem and then out. So it's kind of backwards if you're working, if you have a back-to-back stem plot, okay? Now, if I were to draw kind of a little pattern over this, we don't really have much of a pattern, but I do want y'all to notice our pattern here. All right, so if we're looking at this right here, it might be easy for me to find my median. And I can definitely see that it appears that the ladies did worse on the test than the men did. The A men and the A woman. Sorry. Did you see the little joke about the menu and the woman you? Did y'all see that? Did you? That was funny. So anyhow, I know, but something, something you've got to laugh because you almost want to cry sometimes when you watch, what's going on in our world. All right, so right here, you can see that it's almost bimodal. I'm not sure if I would call this bimodal just because we do have a clear winner with the highest peak being in the 70s, okay? Over here, the men's highest peak is in the 90s. Clearly, the men did better than the women. If the reason that I'm constructing a back-to-back stem plot is to compare 2 categorical variables. Okay, so I was just able to add a categorical variable into a numerical plot, which is kind of cool. Okay, so you can definitely tell that. If I wanted to know the median, the middle number, I could go ahead and I could start marking them. So this is my lowest, this is my highest, this is my lowest, this is my highest, this is lowest, highest, and you could continue to go and mark them off until you got to your middle number. Okay, so you could find your median that way. Or, if you're calculator savvy, I just put all this data in my calculator, it would find it for me. Isn't that fantastic? Do you love that? So it can absolutely find it for you by doing the box plot like we just did, right? And then you press trace and it gives you the data right there. All right, so you can find your middle number here. You can look and find your mode. But a back-to-back stem plot just does allow you to add in a categorical variable into quantitative data. All right, a split stem, this is the next one. It says splitting the stem stem might help you spread the data out more, okay? So we have something called a skyscraper effect and a pancake effect. But let's just say that I was looking at chapter 1 test grades in here. So I have, let's say 7, 8, 9, and 10, okay? And I had a ton of 90s in here, a couple of 100s, some 80s, some 70s. But this was so long, because everybody made 90s, that it gave it, if you turn your head sideways, it's called the skyscraper effect. Clearly, all the data's in the 90s. I got it, no problem. But I might want to disaggregate that data. I might want to spread that data out a little bit so that I can see, did most people make in the low 90s or did more people make in the high 90s? Okay, so I just kind of want to see, okay, you made an A, but what kind of A did you make? Okay, so what we could do is we could split this data. Now, if I really want to look at the 90s and I want to do a split stem, I have to split all of the stems, not just one of them. You have to do it to all of them, not just the one that you feel like doing, okay? So that means that I would need to split my 70 stem, my 80 stem, my 90 stem, and really you would split your 100 stem, even though we know that you're not going to make above 100, okay? So I would split all the stems. So this would be from 70 to 74, and then this one would be 75 to 79. Are those stems equivalent to each other in size? They're the same size, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, so they're the same size, right? And then this one again would be, this would follow the same pattern, 80 to 84, 85 to 89. And y'all can see that this would help me have a better understanding of where my data actually fell, because it would again spread that data out, disaggregate the data, and then I could really see, did you make low A's or high A's, right? All right, so that is what a split stem is. So here's an example right here. This is the total cost of 60 universities, I believe in the thousands. See, it says leaf unit 1,000. So if we're looking at this, we have a lot of schools right here. I want y'all to ignore these numbers. I have a lot of schools right here in the 2000s. It cost about $2,000. I don't know if this is a semester or a year to go to school, okay? And this one is split 1, 2, 3, 4 different ways, okay? So this might be in the, 0, 1, 2, 3, 4, 5, 6, 7, 8. So however it might be split. They did not tell me, but I can somewhat see how this is going to be split. Do you see that this is 1, 2, 3? There are 5 stems with 0. 1, 2, 3, 4, 5 stems with 2. There should be 5 stems with 3 and 5 stems with 0, but there's not, okay? Sometimes Minitab will cut off a stem that is not needed. So the one where it costs absolutely nothing to go to school, we know that's false, so they cut it off. Our highest one is down here at $34,000. Okay, they cut it off after that. Now, what do these numbers mean over here to the side? Okay, Minitab is a computer output program. Awesome class to take in college. Okay, you can take a whole semester of Minitab. All you do is input the data, output distributions, and describe them. It's so cool. So anyhow, take Minitab. I don't even know if it exists anymore, but back in the olden days, it was a great course. All right, so if you look at this, these numbers right here tell you how many are located in your leaves. So this right here, I have one observation. And then I don't pick up another observation in any of these stems until I get to this one that costs $25,000. Do y'all see that? So now the number changed to a 2. So now I have 2 observations. And then you pick up more observations and you pick up more observations all the way. And now this one's weird because it just says a 5. It just stops, and now it went from 29 to 5. That is telling you that the median is located wherever your parentheses are. So wherever you have parentheses, that's where your median is. Now, if you don't remember any of this, guess what? We can kind of make a shortcut. I could put all of this data in my calculator, right? In list 1, and it'll tell me what my median is. Okay, so you might not have to remember this right there, but it's just kind of good to know. And this one's just telling you 5 because there's 5 in this stem. And then again, there's 23 here, and you keep going, that's 24. And this one's odd because look, it goes from 24, and then it says 27. But I only see 26. Do y'all see that? do you think might be happening there? Computer's wrong? So I thought to myself, I was like, well, the computer can't be wrong. So maybe one of them is repeated, right? Maybe there's actually two that cost, 10, or what does that come up to be? $10,000 or 11,000. But that can't be true because if it's repeated, it'll show it, right? This is actually just an error on Minitab. So this actually should say the number 26 right there. So it's very interesting that they actually put this one in your book when there was actually an error in it. But if you look at it, this should be a 26, and then it would count up to it, okay? There should be 60 total. If there is one that is repeated in a stem and leaf, you've got to write it, okay? You have to write it. But that's just an example of how to read a Minitab output. All right, so if it is, let's just go ahead and say that if it has these 5 digits right there, like I said, you can write, could you imagine what your stem and leaf would look like if all the 4 digits were to the left and just the rightmost was to the right? I mean, how many stems would you have here? Like a stem and leaf, that just sounds like stupid. Why would I even do a stem and leaf there, right? What you can do is you can trim it so that you're only looking at the first 2 digits, okay? So if you're just looking at the first 2 digits, which is kind of telling, all right, this one makes 51,000, this one makes 38,000, that's 37. I don't need those last 3 numbers really to look at the distribution of salaries for Clayton County teachers, okay? So what I can do is I can trim it to the thousands place. Now trimming is different than rounding. If I trim, I'm just chopping off the last 3 digits. Look at this 51,880. Y'all would want to round that up to 52,000, right? Because we left it round, okay? But trimming just means you're just chopping off the last 3 digits, okay? So a trim would just mean you were only looking at the thousands place. So where rounding is different than trimming, okay? So whichever you decide to do is fine, but you need to say what you do. So if you get in this predicament here where you're trying to do a stem and leaf, just make sure you tell me, I trimmed the last 3 numbers or I rounded, okay? So either one is right, neither one is wrong, but just look at which method you're going to use there, okay? All right, again, stem plots based on the actual values, very cool. A stem plot, you can actually see the data, which is super cool. Super awkward for you to plot with large data sets or large numbers, okay? So it's broken into groups determined by the number system. So it's not necessarily a good or a bad thing, but if your spread is super long, you don't want to do a stem and leaf, okay? So there are other distributions out there. And like I said, it's kind of an old way of looking at stuff, okay? All right, histograms. Moving on quickly to a histogram. A histogram is not a bar graph. A bar graph displays categorical data. A histogram is a number by count or percents, okay? So you can think of a lot of different data out there that's by the numbers, okay? So you're going to break a histogram into classes or buckets that can be determined by you, or if we're really going to be smart about it, determined by the calculator, okay? And then your display on your y-axis, okay, on your y-axis is either going to be counts or percents, and most likely we're going to start with counts, okay? All of your classes, another word for classes, I like to use the word buckets because it'll make sense to you. You fall into a bucket, okay? So all of your buckets should be of equal width. Same thing with your stem and leaf. They're all of the equal size. So if you're going from, 0 to 9, 10 to 19, and then you keep going, 20 to 29, 30 to 39, 40 to 49. You don't make one of your buckets smaller. They all have to be of equal width, okay, of all the same size, okay? All right, so yes, they are slowed to construct by hand. They do not display your individual data just like a box plot doesn't, but it's very easy for us to read, okay? And we're going to try one in the calculator. Here we go. That's making one by hand. Okay, let's just look at a few of them. Let's do one real quick. You don't have a book, so let me just grab this real quick. All right, we're going to look at IQ scores real quick. I'm going to put it on the board so that you guys can see. And get out your calculators. Let's do one by the calculator. I love our calculator, so we're going to use our calculator. You can do it by hand. It is tedious. You're not going to have to do it by hand. If you do have a book, you can turn to page 49. If not, you're going to get a book in a little bit. All right, here we go. This is going to take a second. 60 pieces of data. Imagine if you didn't have a calculator, so just appreciate the fact when you do have a calculator. All right, I want you to put all of this into list 1. Do you remember how to clear it out? Stat edit, arrow up. So we're on page 49 if you do have a book. All right, arrow up, highlight L1, press clear, enter. Clear, enter. So highlight L1, clear, enter. All right, let's put our data in our calculator. I would go vertically just so that you can read and make sure you get those 5 numbers in. Now, your calculator does not make pretty buckets. It makes beautiful decimal buckets that are not quite as easy to graph. But again, we're about describing the data and not necessarily spending excessive amount of time on creating it by hand. All right, make sure you have 60 at the bottom. Very important that you know that you land on row 61. All right, I'll give you one more minute. You're going to be typing in without even looking in a few weeks. You're just going to be doing this. Okay, so now that we have our data in, we're going to go ahead and do a histogram. A histogram is a type of plot. So second and then stat plot, second and then y equals. And enter into plot 1. So I press enter, now I'm into plot 1. So second y equals and then enter. All right, so we definitely want it on. It is still on from the last time we used it, but we are going to choose histogram. So I want you to arrow down and go to histogram. Press enter so it's on a histogram. All right, our X list, again, we don't have an X and a Y value. This is not bivariate data. It is not 2 variable data. It's just 1 variable. We have 1 variable. It is IQ, okay? So now our frequency is going to stay 1. So at this point, I can zoom 9. Okay, so just press zoom and press the number 9, and you should have some sort of, wow, beautiful histogram show up. Yes, ma'am?
Mine says error when I press it.
Okay, let me check it out here. Yes, if you have any type of issues, I can invalid dimensions. So I know what that is.
I did it last time too, but I didn't put it on yours, but
No, totally fine. Okay, so, okay, your plot 2 is on 2. So that's weird. See how it says plot 2 is on? And you have no data in L2, so it doesn't want to work for you. So it's not that you do anything wrong, there was just something else on. So we zoom 9 now. There you go. Anybody else? Okay? That's fun. Awesome. Mr. Sun. Frequency. Okay, your frequency film. So you're clear. That just needs to say 1. There we go. All right, anybody else? All right, perfect. All right, so this is a beautiful histogram. Now, you could have made your own bucket. So I'm just going to go to the to the book right here, and it says you could have done 75 to 85, 85 to 95. One of them's inclusive, one of them's not inclusive, because one of them, I can't have 85 on one and 85 on another, correct? So which one is the 85 on, the first bucket or the second bucket? The second bucket, because it has the or equal to. Do y'all see that? So just make sure that you do that, if you're going to repeat a number, it's inclusive on one and exclusive on the other, okay? When you're doing an IQ, we could have done like 75 to 84, because I don't think you can get an IQ between 84 and 85, right? It's a discrete number, it's not continuous, there's no decimals in between, okay? So if you look at this right here, that could have been written a different way, or just keep it this way and know which one that it's inclusive on, okay? So if you're doing it by hand, you might have wanted to do that and then counted how many of these fall between 75 and 85. But could you see doing that by hand, you would accidentally leave one out, and then at the end you would notice it's there, and then you got to draw another bar, right? So it's kind of frustrating. So that's why we have this beautiful graph right here. Now, again, we can do the same thing. Press the trace button. And it gives us a lot of information, okay? So n equals 4. That means the number of observations in that bucket, okay, or that class width is 4. Now, look at its class width right here. 81 to 90.142857. Clearly, that is not our class width that we would have chosen if we were doing it by hand, but your calculator has made them all equal, even though it used decimals, okay? And that's totally fine. Your calculator is able to do some beautiful things that we're just not going to be able to do by hand, okay? All right, so, and we can arrow over. We can see that our largest bucket is between 108 and 117.5. If I ask you to sketch a histogram, you can do the histogram in the calculator and then just write whatever your class widths are underneath it. Write your size underneath it, round to 2 decimals. You can sketch it, okay? Sketch means it doesn't have to be dead on beautiful, but I still need to see a display somewhere so I can know what you're talking about, okay? So if I ask you to do one by hand, I don't mind. If the book asks you to do it by hand, you can just do it by the calculator, but you need to write down the class widths, show me what's going on in each one of them, okay? All right, so we can see that most people fell right there. This distribution is roughly symmetric. Do y'all see that? Right here, cut it in half, it's roughly symmetric. I can see that I have a smaller bar here, but overall, I can see that we have almost a bell-shaped distribution, okay? So that is a great way of describing this. When we start describing, we describe it by shape, center, and spread. The shape is roughly symmetric. The center is somewhere between 108 and 117. The spread of it, y'all remember the range, the least to greatest? So that's going to be your first spread. Then we'll move to standard deviation, we'll move to interquartile range and all that. But the spread of the data can be least to greatest when you start out, okay? All right, so that's really, really good to know. All right, so the other thing that I do want to show you, so one more thing about the calculator, I want you to press the stat button. Last new thing, stat. Go over to calc, so arrow over to calc. And we have something called one variable statistics. That's what we're doing, one variable analysis, so press enter. And it's going to ask you, what list do you want me to give you data on? L1. Frequency needs to be 1, not L. This is probably from chapter 8, so I'm just going to clear that out. And you can either leave it blank or maybe put a 1 in there. It's going to tell me if I'm wrong. So it's either blank or 1, okay? And then you can go down and calculate. And mine did it for me. Perfect. All right, so this gives you a lot of information. Some of it you will use. We had 60 pieces of data. Right here, this X bar, that is my average. That is my mean. So X bar is your average or mean. So my average IQ is around 115. This is the sum of all the IQs. That really doesn't mean a whole lot to me. This is the sum of the IQs squared. We're not going to use that right now. Standard deviation, arrow down. And this is kind of the fun stuff right here. This is called my 5-number summary. This is what makes your box plot. your min, your max, your median, your Q1, your Q3. Do y'all see that? So it gives you all of it and it's broken into quarters again, okay? So all of your information is there underneath one variable stat. All right, just gonna finish up, and what time did we get out of here? 9:35? Okay, I'm almost done, bless your heart, I know, I'm rocking it. All right, so now we know how to make a histogram, go in the calculator, all right, talk to me about the shape center spread of this. What is the shape of this? Is it unimodal or bimodal? Does it look like it has one mode or two modes? Unimodal, okay, it's one peaked or two peaks, okay, so definitely looks like it's one peak there. Does it look roughly symmetric if I were to fold it in half?
Not really.
Roughly, y'all don't like it, I know, but you're gonna learn, you're gonna be like, heck yeah, that's roughly symmetric. All right, so yes, it does look roughly symmetric. I know this one looks a little bit higher than that one, this one's a little bit higher than that one. If I were to collect 5 more pieces of data, it might come out to look more beautifully symmetric. You'll notice that a pattern will emerge the more data that you collect, okay? So right here, I don't know how much data I have. Actually, I can figure it out by looking at the height of the bars. That looks about 16, that looks about 10, 10, that looks about 3, 2, maybe 3, 4. So I can look at the data and count how many there are. I know that there should be 60 total, right? So do you think that I can eyeball this and figure out where my 60 are? Heck yeah, absolutely I could, okay? All right, so it does look shaped, looks roughly symmetric. The center of it falls right here in this class width right there, or in that bucket. The spread of it looks like it goes from, oh gosh, what do y'all think that is? Just the 80s? That was kind of weird to read because it doesn't give you a class width. I guess it's all of our 80s right there. I'd have to look back to what they did in the book. They did 75 to 85. So it looks like 75 to 85, 85 to 95, 95 to 105, 105 to 115. So that's where it looks like the bulk of our data is. So my center would be there. My spread is from 75 to 155. What does an IQ go up to?
The highest ever was 210, I think.
Woo! Okay.
Who?
I don't know, he killed himself.
Oh my God.
He went to college at like 13 and everyone made fun of him because he was so young.
Emotionally, you might not be
Yeah.
right. I mean, again, you can have full of knowledge, but emotionally, that would probably be very hard. All right, so like I said right here, I said this with your stem and leaf because it relates to a histogram. A skyscraper effect is if you have too many or too few buckets, so everybody's in the same bucket because you only have 3 buckets, right? Or a pancake effect is if like you made way too many buckets and there's only like 1, 1, 2, 1, 1, 2 because you made too many, you spread it out too much, okay? The beautiful thing about the calculator is it'll make the buckets for you, okay? All right, shape. Again, this is the one I think you guys missed out on yesterday. We can have a normal bell shape. This is also called symmetric, where the mean and the median fall at about the same spot. This is very important. Put like a heart, a star, something around there. You can have it skewed right, where you have a few high numbers that are pulling my mean into the tail. Let me give you an example. Right here, if it's skewed right, so we're looking at the average salary of somebody that lives in Bremen. And then we have an NFL player from the Falcons decides to move into Bremen. And then we do the average salary again. Is his salary going to pull up the average, the mean? Yeah, so it's going to look like people in Bremen make a lot more money than they actually make because we have somebody that's making in the millions, okay, living in our town, okay? So what that's going to do is it's not going to pull up the median. If I have a bunch of numbers and I just put a high number on the end, I'm still counting to the middle for the median. So the median is resistant to crazy outliers, but your mean still gets pulled with outliers, right? So when they talk about median income of a household or median something, they're using the median because it's not skewed by high or low numbers, okay? So you can see that the mean is pulled into the tail because we have a few high numbers. Same thing right here. This would be like your grade on the Chapter 1 test. We have a few low scores. So if I reported your Chapter 1 test, the bulk of you made a high grade, but a few of you made a low grade, it wouldn't be fair for me to report the class average, okay? Just because I had 2 people that made 20s, it would pull it down. Maybe I need to look at the median test grade instead. Do you see? So the median is resistant to outliers. I want y'all to star that. You definitely need to know that. All right. So the median is the equal areas point because it's your 50-50. And then the mean is kind of the balance point of it if you're kind of looking at a scale there. Okay, histogram, like I said, we're looking at shape, center, spread. Is it roughly symmetric? Is it skewed? Is it unimodal, bimodal? The middle, we're generally talking about the median or the mean. This is a big one. Let me just go ahead and put this down. All right, the center. Do I use the median or do I use the mean? Which one do I use? Shouldn't it depend on the shape of the distribution? If it's skewed, I better use the median. Because I'm not going to let that NFL player really show that the salaries at Bremen has increased that dramatically. It's not fair, okay? So we're not going to use the mean on skewed distributions. We're going to use the mean on symmetric or bell-shaped distributions. Does that make sense? Why? Okay? So that's really important to know. So on a test, don't give me both of them. Give me the best one. I'll count off if you give me both of them. Don't give me the mean and the median. I want to know what center is most appropriate to use. Okay? All right, and then your spread right now is the overall range, and you do need to document outliers, shape, center, spread, and any abnormal things happening. Holy smokes, we have a guy that had an IQ of what?
210.
210. I might need to document that. I have an outlier. Okay? I always use Miss Scott as an outlier, right? Right? So she's an outlier if we're looking at the distribution of heights of teachers, right? Absolutely. Okay. So now, an outlier doesn't mean it's a bad thing. You have an IQ of 210. Wow. Okay. It doesn't mean that it's a bad thing. Usually we do have an outlier in class too. Like I'll have somebody in here that is super tall or super short or has tiny feet or something like that. So it's not a bad thing to be an outlier, but you do need to point it out. Okay, shape, center, spread. All right, so look for points that are clearly apart. Those are called outliers. Outliers can mean that you accidentally typed in a number wrong. I forgot to put my decimal, so I had 34 instead of 3.4. Something's wrong. I need to look at my data. Is it wrong or is it just there? Okay, is it naturally occurring? All right, look at this one right here. Clearly, I have a roughly symmetric. My shape is roughly symmetric. I have outliers on both ends. Well, this isn't really an outlier because there's two of them, but I definitely have an outlier over here on this end, and I have two missing buckets. Do y'all see that? Two missing buckets and then another number. That means that's definitely an outlier. Over here, I only have one missing bucket and then a few, so that might necessarily be an outlier. That might not be an outlier because there's only one missing bucket and there's several of them occurring there, okay? So that doesn't feel like an outlier to me. This one, two missing buckets, and then an outlier, okay? Something hanging out by itself on the end, okay? My shape, roughly symmetric. My center, somewhere around this, what is that, 1250 to 1500? There's my center, and then my spread would be from 0 to, what is that going to be, 3250, okay? So, this one, oh, that is beautifully, beautifully symmetric, okay? Shape, center, spread, no outliers there. We can see that my center's right around here, roughly symmetric, unimodal. And then you can see this is the percent of New York Stock Exchange stocks. This is our return right here. So we have a negative return all the way up to a positive. All right, what is this one going to be called? Skewed right, whatever which way it's tailed. So if we have our shape, center, spread, this is definitely, so shape, center, spread, and we need to add our outliers. All right, so my shape is definitely skewed right. Oh, my center! This one's kind of hard, isn't it? All right, so this is interesting that your center, what center would I use on this one?
Median.
Median, okay? So we're definitely going to use median because you know that the mean is definitely skewed here, okay? So we're going to use the median. It's generally not at your highest peak. Not at your highest peak. It's usually at the one that's directly next to it. So if you had to eyeball it here, first of all, if this were on an AP exam, you would know that I'd be putting all of this data in my calculator somehow. Okay? This is 0. I'd put 15 zeros in my calculator. I just would, okay, to make sure I'm doing it right. Then this is 1. I'd be putting about, I don't know, 11 ones in there, and I would be eyeballing it that way, okay? Now, my median is probably somewhere around approximately 1 on this one, okay? It's usually at the peak next to the highest peak, okay? Remember, it's the 50%, right? So could if I'm looking at this data, and I know there's 15 pieces of data here, 11 here, 5 here, 11, what do y'all think this is? 7, 6, 2, 3, maybe? 2, 1, 2? Okay, so now I've looked at that. Where's my median? It's the middle number. How many pieces of data do I have? And I need to have the same amount on the left and the right, so my median should be somewhere right around there, okay? My median might actually end up in this one right there, okay? So I could say approximately 1 to 2. So isn't that do you see what you could do there? You don't just have to eyeball it necessarily, you can start putting calculations in there. Okay, so I have 26 pieces of data there, then I start adding this up, and I need to see how many, if I have 50 pieces of data, I'm somewhere around 25, right? So that's where you need to find out what that middle number is. All right, so my spread goes from what, 0 to 10 is my range. And we're not going to use range but for a few days, because then we're going to get more specific. We're going to use interquartile range, which is our middle 50%, and we're also going to use standard deviation, which I'll explain to you. All right, outliers, there are no outliers. All right, beautiful. Again, my shape here roughly symmetric. My center definitely around 12. This means that my center on this one, my mean and my median are located at the same spot because it's roughly symmetric, okay? So my mean and my median will be somewhere around 12. My spread is from 7 to 17, and there are no outliers, okay? So just look at these and make sure that that you're aware of how to go through and do that. All right, I already showed you how to do histograms in a plot. Tomorrow I'm going to go over it's called the ogive, okay? Not the ogive, it's called the ogive. I'm going to go over this one tomorrow because we're kind of running out of time, but we will have plenty of time tomorrow, okay? All right, so tonight, your homework, you are going to need to grab a book, and you have to do problems 1, 7, 11, 13, 23, 26, and you have 2 videos to watch. Your homework is taken up at the end of the unit. Did you hear that? I'm not going to take it up till the day of the test. When's your homework due? The day of the test. Okay. So I'm not going to take it up. You're going to staple it all together on the day of the test, and that's when you're going to turn your homework in. So everybody, you don't have to grab a book. I'm going to show it to you up here. So please, eyeballs up here so you can see how to find your homework. All right. You will have something called X. Whoa, y'all can't see that. Hey. Close out. And that. All right, so in your book, you will have something called exercises. Now, notice that one says 1.1. Do you have to do 1.1 tonight? Look on your unit plan. What's it say over there? Does it say 1? It'll say 1.1 on your unit plan. That's it. Chapter 1, problem number 1. Then you've got to do number 7, right? What's the next one you have to do? 7. So you need to look for 1.7 under exercises. Not figure, but you're going to keep going. There's 1.5, there's 1.6, there's example 1.6. I've got to go to exercises and find, there it is, exercises 1.7. Okay? So that's how you're going to find what your homework is. It's under exercises. It's not figure 1.7, it is exercises 1.7. Okay? So that's how you're going to find it in the book. Okay? All right. Daily videos should be listed in AP Classroom. So you have the 1.4 day 1 and day 2 videos. It was assigned to you. If you can't find it, let me know, because again, this is my first semester doing the daily videos instead of Edpuzzles. So it should have been assigned to you. There is no due date on it, but it will tell me whether it's a daily grade, whether you watch it or not. Okay? And then work on your homework. If you don't get it all done tonight, that is okay. You won't know how to do the ogive thing yet. I'm going to go over that with you tomorrow. Okay? All right, y'all take a breather. Good job today.